What is up, math superstars? We are in part 3 of our volume and surface area series. This is what happens when we have volume of a rectangular prism if we changed one of the attributes of the rectangular prism. So if what happens if we change length or width or height? So let's go ahead and see what happens. So we have our original prism. If we did 4 times 3 times 2, that's going to give us 24 as our original. So next one is, what happens if we multiply the length by 2? So our length will now be 8 times 3 times 2. So we have 8 times 3 is 24, times 2 is 48. What happens if we just did the width by 2? So our length will be 4. Our width now is going to be 6. So we multiply by 2. And our height will stay the same at 2. So 4 times 6 is 24, times 2 is 48. And what happens if we did the height times 2? So our height times 2 would be 4. And then let's rewrite our other attributes based off the original. So now we have 4 times 3 is 12, times 4 is 48. And so some things that we notice here, that if we're going to multiply one of our side lengths by 2, it's going to double our volume. So in conclusion, when the length of one of the attributes of the prism is changed by a scale factor, so whatever it's multiplied by, the volume, so the total volume gets multiplied by that same number. So once again, if we're doubling one of our sides, it's going to double the volume. So here we have this example. Company is producing 3 sizes of cereal. The family size is 2.5 times wider than the original box, while the smallest box is only 1/2 the height of the original. So now we need to compare the amount of cereal that the boxes can hold. And so here we have delicious space flakes. And let's go ahead and figure out some key information before we compare the volumes here. And so in this word problem, the family size is 2.5 times wider than the original. So let's go ahead and look at family size, and let's go ahead and figure out the width. And so the width is just 2.5 times 2.5. And when we do that, it comes out to 6.25 inches. And we know that the height stayed the same for this one, and the length stayed the same for this one. Now let's go and figure out our smallest size. So our smallest size is half of the height. So we're going to take our height, so it'd be 12, and we're going to cut it in half by 2, gives us 6 inches for the height of the small size. And the width stays the same, and the length stays the same. So now let's go ahead and compare the volume here. And so what we're going to do is we're multiplying length times width times height. So 7.5 times 2.5 times 12 gives us a volume of 225 inches cubed. So let's take a look at our family size. So our family size is 7.5 by 6.25 by 12. I'm multiplying those together to get 562.5 inches cubed. And our smallest size, 7.5 times 2.5 times 6 gives us 112.5 inches cubed. And so now we can go ahead and compare the amount that each box can hold here. And so for the smallest size is half of the height. So if we took the original size, 225, and if we divided it by 2, it should give us 112.5 inches cubed. And so we did half the height, we got half the volume. And so now for our family size is 2.5 times the size. So if I do 225 times 2.5 gives me 562.5 inches cubed. So when I multiply the width by 2.5 from the original, the volume from the original also gets multiplied by 2.5 to get my new volume. And so we can see that by changing one of the sides, that scale factor, whatever we multiplied by, the same thing happens to the volume.